podcast where we talk to smart people, but not necessarily done by smart people?
That is an awesome question.
This one goes down probably on one of my top 5.
Hey, I like nutrition. I like to eat food.
This is the coolest thing ever. We're going to do this forever.
I wish I paid more attention in that class.
You know, I'm going to be honest, I don't understand that. As a man, I don't get it.
Welcome to smartpeoplepodcast.com.
Hey, and welcome to Smart People Podcast, conversations that satisfy your curious mind. This one is going to satisfy some curiosity. I don't know if you've ever thought about how curious you are on this topic, but man, we talked to a smart guy today, Professor Dr. Daniel Cloud, but he prefers to go by Dan. Dan teaches philosophy at Princeton University, but he took an interesting way of getting there, and we talk about his journey, which is one of my favorite things to do. He traveled to China, taught English. He then became an equity analyst. After that, he went back to Columbia University's School of International and Public Affairs, did some more things in finance and business. Then he went back to Columbia and got his Ph.D. in philosophy. He's written 3 books. We talk about 2 of them, actually. One of them, Schrodinger's Crystal, he answers the question, what is life? And that's kind of early on in the episode. It can get a little heady there for a few minutes, but I promise it's worth the payoff. I actually really like the conclusion he came to there. And then as we continue to dive into evolution, the evolution of language, his newest book is called The Domestication of Language, Cultural Evolution and the Uniqueness of the Human Animal. It's not so much about language. This episode, definitely, we don't talk too much, but more about evolution, how societies evolve, and how language is a great lens to look through when looking at evolution. Really eye-opening. I love talking to philosophers. Head on over to smartpeoplepodcast.com, sign up for our newsletter. We love connecting with you guys. I am actually determined, so I'm going to put it out there. I am going to start a LinkedIn column where I'm going to talk about what I learned from each interview. It'll probably focus a little bit more on business, but when there's times when I can pick out some great things, I'm going to put it up there. And also, hopefully that will then get incorporated into our newsletter. Obviously, I'll link to that. So that's another reason out of many to sign up for that newsletter right there. And if you wouldn't mind, leave us a rating on iTunes. We'd really appreciate it. If you enjoyed the show, that's a way to help us out. Here is our interview with Dan Cloud. Dan, thanks so much for being on the show. Really excited to talk to you and learn all about language, the evolution of language. It's something that I've never really thought about until I picked up your book. And the first sentence, I read it and I thought about it. It says, how did all the various things in the world get their names? And I was like, well, I have no idea. So I'm glad we have the man who solves the mystery on the phone. Thanks for joining us.
Oh, it's great to be here.
So first, I kind of wanted to talk to you about your background. It's really interesting. As I was reading your bio, it looked like you went to school, you first taught English, and then you traveled a bit and did a lot of business, economics, investing, it sounded like. Eventually found your way into philosophy and now being a professor at Princeton. So I was hoping you could explain how that all worked out and the triumphs and tribulations in all those movements.
Yeah, well, it does kind of look on paper like I did a lot of different things. But from my point of view, it was really all pretty much a single-minded pursuit of a single goal. When I got out of college, I really wanted to know how things work. And part of knowing how things work, how the world works, how society works, how this big environment that I was moving out into really is set up and how things really happen and who really runs things and so on and so forth. And, part of what you need to find out to get an answer to that question that satisfies yourself is stuff you can only find out by going and taking risks and getting involved in things and subjecting yourself to the vicissitudes of fortune. And part of what you need to know to understand that is stuff you can only learn at a university by reading books. and listening to professors and having your papers graded. So if you really want to understand people, you kind of have to do both things. You have to spend some time on theory, and you have to spend some time on experimenting. And experimenting, when it comes to human beings and human society, means trying to do stuff, trying to accomplish stuff, and seeing whether or not your idea about the project is correct and whether it succeeds or fails. So, the question for me was just what order to do these things in. Should I get the schooling first, which is what most people do, and then try and get experience of the real world? Or should I get the experience of the real world first and then try and get the schooling? And it was a kind of a simple choice from my point of view, because I didn't really think I could afford to go get a Ph.D. in philosophy and do something impractical like that. I thought I'd better take care of the practical aspects of life first, and for that I needed a job. And I didn't really have any prospects or connections when I got out of college. And China was at sort of an interesting point then. It was just opening up, and it looked like it would be an interesting thing to get involved with, and maybe I could get a job or something if I learned Chinese. So it just really started with that, with just kind of flinging myself into the Chinese reform process in 1983 and spending a year as an English teacher at Tsinghua. And then it's all been pretty much one consistent project for me from there.
Yeah, I mean, it sounds like you have the philosopher in you from the beginning, right? To go out and approach things that way, as trying to learn, trying to experience, trying to figure things out, as opposed to many who might look at it as less of a journey and more of just, this is what I do, go get a job. And, you worked as an equity analyst and whatnot. And so you could have just said, this is what I'm doing. I'm making good money. I'm going to stick with this.
Yeah, no, I mean, I think if you end up as a philosopher, it's because there's something horribly wrong with you that you couldn't possibly, it would be better to do something else. But people end up as philosophers because they can't stop thinking about particular subjects. If you get hung up on something and you have to know, and you sort of can't go on with everyday life. So, I think it was good to at least make an attempt to participate in normal everyday life and do regular things. But in the end, I think I've really been a philosopher since I was 8 years old. And so I was going to come back to that eventually.
It's really great talking to somebody like yourself, because I often find myself in that situation where I'm just hung up on a lot of the things. Actually, I want to touch on a dissertation you wrote, and I can't pronounce it, Schrodinger's?
Yeah, Schrodinger's crystal.
Yeah, so I do want to touch on that. But before that, now looking back as we discuss it, you say, I kind of knew where it was going. It was one singular path. Here's how I went about it. Do you remember during that time, was it ever stressful? Because you knew you wanted to get to this, maybe it was the PhD in philosophy, but you had to go through other things first, which could be seen as just roadblocks, as just challenges to be overcome, as opposed to part of the journey.
Yeah, well, I mean, I'm not going to claim that it wasn't stressful, because some aspects of the whole thing, like the time I spent in Russia, were incredibly stressful, actually. That was a weird thing for a guy who was going to end up being a philosopher to do, was go spend a few years hanging around with a bunch of people who were basically gangsters. So I don't want to claim that it wasn't stressful. And I didn't really have the idea that I would make it all the way through to the point I'm at now. It was kind of an idea that it would be really cool at the end to go back and get a PhD and become a professor and do something more theoretical about the practical experiences that I was having. But I never really believed that I would get through to that point. It was just a kind of a distant, unrealistic goal that was on the horizon. It was something to work towards if everything went really well. Each successive thing, they may be simple things for other people, but for me they were incredibly hard, each of the things I did, and I was really doubtful that I would succeed with each one. But I guess it's just a certain personality type that you keep flinging yourself at challenges that are just a little too tough for you. And a lot of people do that, and it doesn't really work out well for them. I guess I happen to be lucky that I kept flinging myself at challenges that were a bit too hard for me, and then somehow having the good luck to get through them.
It's funny to hear philosopher kind of end up saying it was luck in the end. I don't know if I feel good or bad about that.
Well, and I mean, nothing more so than philosophy. It's incredibly hard to really come up with something that's an interesting contribution. And it is a lot a matter of luck. It's a matter of what you know going into it and what happens to be happening at the moment. It's really, really unlikely. I mean, it's a quixotic project, philosophy. It's really, really unlikely that when you start out that you're going to end up making a genuine contribution to the Western philosophical tradition, because that's so hard. I mean, so few people have ever done that. I think way more people have climbed Mount Everest than have made meaningful contributions to the philosophical tradition. So you just really have to be kind of nuts to take a thing like that on in the first place. And I think I'd be lying if I didn't say that there's a big element of luck in even just getting through the Ph.D. program.
Sure. Well, I appreciate that. And before we move on to talk about your new book, The Domestication of Language, which is fantastic, and I can't wait to get into it. As I mentioned, I want to talk about Schrodinger's crystal. And really, just the fact that when I was reading about it, you talk about how it explores the question, what is life? And if I have a philosopher on this podcast who wrote something about what is life and I don't ask them, then I have a serious issue. So did you come to an answer? I need to know. I'm dying.
Well, I came to an answer that's satisfying to myself. I came to an answer to the question that I was asking, but there are actually a lot of different questions that have the English pronunciation. What is life? There's about 117 different things that you could possibly be asking when you ask that question. So one of the things that you have to do to get anywhere at all on saying anything interesting about that is to have some understanding of what version of the question you're trying to answer, exactly what it is that you're asking yourself, because the biologists have a pretty good answer to the question, much better than mine, I think. Like, it's a pretty convincing. You just go read Molecular Biology of the Cell cover to cover, and you'll know a lot about what life is. It's a 2,000-page book. There's all kinds of information in it, and it is full of great discoveries. This is a great age in biology, and there are lots of great biologists working. As a philosopher, the question that I'm asking when I'm asking what is life, I don't want to know all of the details of how particular types of cells in the human body work. That information is relevant, but it won't answer my question. What I want to know is, in the most general sense possible, what is life? What would life be, not just on other planets, but in some other universe with different laws of physics? Which things would count as living and which things would count as non-living? What is the phenomenon in the most general sense possible? So I have to abstract away from all the hard, nitty-gritty details that are contained in molecular biology of the cell and say, well, gee, what's really important about those carbon atoms? What's really important about those hydrogen atoms? What's really important about those protein molecules? What features do they have that you'd absolutely have to have for something to count as a living thing? And you end up with a different answer if you ask that version of the question. So my thought was, well, these living things, there's a lot of different ways you could look at them. But one of the ways you could look at them is you could say, well, here I am in this environment, and there's some rocks lying around, and I understand how the rocks were formed and what's going on with that. And there's maybe some quartz crystals. And then there's these plants. And can I fit the plants into the same kind of story about matter and pieces of matter interacting with other pieces of matter that I explain the quartz crystals in and that I explain the rocks in? And I thought Schrodinger had something really intelligent to say about this. He said, well, really, if you look at a protein molecule, what they knew less then than we know now, but the idea basically has survived. If you look at a protein molecule or some DNA molecule, what's different about that from the arrangement of atoms in a crystal or any kind of normal non-living material you might find is that there's a pattern in the for example, in the long DNA molecule. The things in the molecule are meaningfully related to each other. Something over here has to be a certain way because something way over there is that way. But the pattern isn't a regular, repeating, periodic pattern. It's not the same pattern over and over and over again. Your genome doesn't consist of the same gene repeated 100 million times. It consists of 100 million different genes. So the sequence, there's what's called a long-range aperiodic order in the sequence of your genome. And that's true of protein molecules. And if you go through and you look at the biological molecules in general, like what's really that it really does, some of them are periodic, the ones that play structural roles. But the molecules that play informational roles and a lot of the proteins in a cell, what's really strikingly different about them is that they have structure, but it's not a periodic structure. So I found that idea in Schrödinger, and then I looked at what people have done since then with the idea of aperiodicity, of aperiodic patterns. And what I found was that now in biology in the 21st century, in the last 15 years, the same idea has come up in biology again in a somewhat different form, with the idea of what are called Wang tiles. A mathematician named Hao Wang, discovered in the 50s and 60s, that you could make sets of dominoes that would carry out specific computations. If you arrange the dominoes correctly, you have these square dominoes, and they have colored sides, and certain colors can only go together with certain other colors. That if you set up the colors of the dominoes in exactly the right way, and you set up the rules about what domino can stick to what other domino in exactly the right way, then you can get a set of dominoes that will calculate the answer to some mathematical problem or solve a chess problem or something like that. And people in biology have begun to, so it's a different way of thinking of computation. It's not thinking of computation as a process, it's thinking of computation as a kind of a geometric thing involving things arranged in certain sorts of patterns. Mm-hmm. And people have in biology have taken up this idea. Again, there's a lab at Princeton where they made a bunch of Wang tiles out of RNA atoms, and then they solved chess problems with them to demonstrate that you could make a molecular computer on this basis. Mm-hmm. So this is kind of a complicated story, but what struck me about Wang tiles and the idea that you could have a specific little set of things that could be computationally general is once you have a computationally general device, you can generate any pattern whatsoever. So what I got out of the idea of a periodic order in Wang tiles was that there's some set of little atoms or little molecules that if you assemble a sufficient set, 20 or 30 things, you're going to be able to make any shape whatsoever out of these basic ingredients. They're going to be sort of a set of universal tinker toys that are going to allow you to make any shape whatsoever. And really the essential feature of living things, the most basic feature of living things, you find this in Darwin, and it's still in molecular biology, the cell today, the most different thing about living things from other kinds of matter you find in the universe is the division of labor, is the fact that there's lots of different kinds of molecules in the cell, each of which only does one thing. Whereas in a crystal, a salt crystal, it grows. All the little parts of the salt crystal are basically doing the same thing. They're sucking up sodium and chlorine atoms and arranging them into boxes. But a cell has lots and lots of different kinds of molecules that do lots and lots of different little tasks. And the way you get that is by being able to make any sort of molecule whatsoever. And the reason you can make any sort of molecule whatsoever is because there's enough complexity in the basic ingredients that you've got a set of tiles that's basically computationally general and can generate these large aperiodic ordered structures. So, what would be essential in what life would have to have in any universe whatsoever is some set of basic constituents that are complicated enough that they can produce enough varied different kinds of parts so that a division of labor, a meaningful division of labor, can really emerge. That's why there's life in the universe is because since the plant is dividing the labor in the cell between thousands of different kinds of molecules, it can do the work of replicating itself much more efficiently than a crystal can. And so in certain kinds of situations, you're just going to find plants instead of crystals.
I know it might seem hard to believe, but that actually makes sense, even to the layman. Like, I really enjoy that comparison or that example of the cell versus the salt crystal. It's a good explanation of that. And it also you tied in some of the things that you now talk about in your new book, The Domestication of Language. You talk about evolution and kind of Darwin's theory and how those things change over time. And so there is that similarity or that linear path between what you found there and what you're writing about now.
Right. Well, I'm trying to understand evolution in general. The evolution of human culture and the evolution of biological organisms. And one of the questions that I was interested in Schrodinger's crystal in my thesis was, is evolution going anywhere? Is there any tendency for things to get more complicated or to approach a certain particular end state? Is this a teleological process is God evolving? Is that what's happening in evolution? Or are things just kind of going back and forth, getting more complicated and then getting simpler again and then getting more complicated again and then getting simpler again? Or what's happening? Where are we going with this? And the beauty of the idea that the fundamental feature of life is the aperiodicity, the non-periodic nature of the constituent molecules, and the computational generality is playing a role in that. The beauty of that from the point of view of talking about where evolution is headed is it gives you a story about what lies at the end point of this kind of process of developing larger and larger and more complicated aperiodic patterns. This is a little bit, we would have to get into the weeds a little bit for me to prove this, but what you get out of the idea that the fundamental feature of life is its non-periodicity is you get the idea that there's not one end that it's tending towards. There's not one infinitely complicated thing that would be produced at the end of time if evolution went on for infinitely long. There's infinitely many different ends that you could actually arrive at because there's infinitely many different aperiodic patterns. In fact, there's uncountably many different aperiodic patterns, which is uncountably many is even more than infinitely many.
Huh.
So it means that if you want to think of this, the world is evolving towards something, you can't think of it as evolving towards one particular deterministic thing. You have to think of it as evolving towards one of infinitely many things, all of which are very great and wonderful and complicated.
Sounds complicated. I'm going to be honest with you.
Yeah, that part is a little bit technical, but it's interesting to know that we're not just headed inevitably to one final state of affairs, that there's lots of different directions we could go in evolution.
Sure. Well, and so I did want to talk about this because it's interesting. You do use language as a means to discuss evolution. And that's the most unique aspect of this book, of reading it and of thinking of things this way. So first, let's talk about how you linked, Darwin's theory to the evolution of language.
Yeah, well, the whole idea of cultural evolution. I mean, the interesting thing about this is that the idea of cultural evolution is older than the idea of biological evolution. A big influence on Darwin was reading Malthus. Malthus's book about the dynamics of populations and how things have tended to change over time. And one of the chapters in Malthus's book is his theory of cultural evolution, his theory of how people get so warlike. He says, well, you just have this continuous overpopulation, and so tribes have a tendency to push against their neighbors, and the ones that are more warlike tend to win out in the end, and so that's how you get all these ferocious people. That means that right at the root of the whole evolutionary tradition of evolutionary thought, before you even get to Darwin, there's an idea about cultural evolution, about how people's culture must change in some particular set of economic circumstances. And Darwin kind of had ideas that came awfully close to this. In Variation of the Animals and Plants Under Domestication, which nobody ever reads, and in the late parts of Descent of Man, he talks about the evolution of self-adornments, because he was really interested in things like 3 different times human beings have invented the custom of putting an extremely large plate in your lower lip. And there's also lots of cultures where people put big hoops in their ears. And there's cultures where people flatten their infant skulls to produce a particular head shape. And so Darwin kind of got interested in that. And the question he asked himself was, well, gee, wouldn't that look grotesque to the people? Or wouldn't they stop? Why would a person, put a big plate in their lower lip or flatten their baby's head? How could you even get to that state of affairs? And his idea was, well, the essence of fashion is that people want to see just a little bit more. whatever the characteristic thing is of the appearance of people, in the group, or how people dress or something. People just want a slightly exaggerated version of that. And so you get the large plate in the lower lip. You start out with a really small one. It's just considered attractive to have a sort of a big pouty lower lip. And then generation after generation after generation, parents are competing with each other to produce slightly more exaggerated versions of the feature. And at the end, you get this great big huge ornament that looks really strange to people from other cultural backgrounds. And it's interesting that almost every human culture has something like that. They pierce their ears, or they scar their faces, or they do something that marks them as a member of that particular culture and is some kind of evolved self-adornment. So the thought, in the book about cultural evolution is, well, gee, if that's how ornaments evolve, if that's how hairstyles and ways of putting hoops in your ear evolve, I wonder if I'm surrounded by all kinds of other stuff that's evolved in more or less the same way through a series of incremental exaggerations, little slight exaggerations, and things looking kind of cool to people and then wanting to exaggerate them a bit more. But stuff that's perfectly familiar and that doesn't look grotesque in any way, or that's even rather functional. Couldn't there be a lot of stuff around me that's evolved in the same way? And what is the analogy Darwin is really pushing here? He's pushing an analogy between domestication and cultural evolution. He's saying the hairstyle or the lip plate or the hoop in the person's ear, it's evolving by very much the same mechanism as a domesticated dog or a domesticated pigeon, which is another preoccupation of Darwin's, is domesticated animals. So isn't there some way of taking that idea of his, which is buried in a couple of very obscure places, and really running with it? And what's a good example of human culture? And language ends up being a good kind of culture to use, a good thing to work on. If this is your general theory of cultural evolution and you want to fit it down to some very specific phenomenon, this language and words in particular are a good place to do it, because there's a lot of philosophical work on words already. So I have this very rich tradition of ideas that I can already use to make the theory out of. And also, the oddity of words having particular meanings is something that everybody is familiar with and everybody encounters every day. I don't know if there's anybody who, as a child, hasn't wondered why a word like sofa or cellar means the particular thing it means instead of something else, and why don't we use the word cellar for sofas and the word sofa for cellars? It's really awfully mysterious, and it's a familiar mystery. It's one of those mysteries that people's encounter all the time, just in the course of their daily affairs, like the mystery of time, which is another beautiful philosophical mystery. So I thought, well, there's a really serious Darwinian theoretical idea here, and then there's a familiar philosophical mystery that we all encounter as children, and can I figure out a way to make them go together and yield some nice theory of how the meanings of words change over time?
Well, so the idea of evolution, as I understand it, is that things get better over time. Survival of the fittest. The newest model's better than the older one. Does that reign true in language, that we are creating a language that is more useful as time goes on? Because when I say I watch Romeo and Juliet, or something along those lines, I think their language is much more beautiful. It oftentimes sounds more elegant and perhaps more descriptive in comparison to some of the things we talk about today and some of the words that are becoming official parts of our language.
Right. Well, I mean, first, let me correct you a little bit. Fittest in evolutionary biology doesn't mean best. It means most likely to have offspring. So there isn't really, in the mechanics of the theory, there isn't really an obvious way in which it's driving things to improve over time. It's just driving things to be well adapted to the environment that they find themselves in, which is a slightly different thing. I have this other idea, that actually there is some tendency happening over time, but that's just my idea. That's not part of the basic mechanics of Darwin's theory. Having said that, I think English in particular, you have to say that in some ways it is getting much better over time, or a much more powerful language for expressing thoughts. It's just that it's in a way that's maybe more beneficial to our society as a whole than it is to us as individuals. It's changing under pressures that are coming from the larger society in ways that maybe are not great for us personally. What I mean by this is that English is the most pronounced example that we have yet of natural language fragmenting into thousands of different technical languages. If you think about it, probably 1,000 years ago, there were very few technical languages. There might have been technical languages for talking about sin or some kind of set of technical terms in theology. But most people would never really encounter a term that was part of the technical apparatus of some specific scientific or engineering discipline. And over the last 1,000 years, we've developed, hundreds and thousands of distinct technical languages, all of which have some connection to English. There's an annex of English that involves all of, the terms that people use in calculus. And there's an annex of English that involves all of the terms people use in abnormal psychology. And there's an annex of English that involves all the terms that people use in trading options. So, Wittgenstein's image of this is you have this old medieval city, and then in its suburbs you have all these giant, huge, modern buildings that are sort of don't have the heart of the nice old medieval castle and cathedral in the middle of the town, which are the center of people's whole lives and whole culture, but which each of the modern buildings out in the suburbs nevertheless perform some particular function really well. So it's, the complexity of a modern society means that the whole thing is too complicated for any one person to understand, and it also means that it's too complicated for any one human language to be adequate to describe or to use as a tool of communication in managing it. And so we end up as individuals kind of confined into semantic worlds of meaning that are sort of narrow, that maybe aren't broad enough to encompass every aspect of our own personal lives and the sort of things that people actually worry about. And that's what the philosopher is trying to do. He's trying to put the language back together. He's trying to keep it from shattering into 1,000 different pieces that don't communicate with each other. And he's trying to keep the society from breaking down into 1,000 little tribes of sort of techno-savages, each of which thinks that the others are idiots. He's trying to keep alive a language in which everybody can communicate with everybody about pretty sophisticated things. But yeah, it is sort of a problem that we have all this special use language.
It's interesting because when you bring the idea of different cultures in, I definitely wanted to ask how we ended up with so many different dialects even today. But in that same token, I'm thinking the human condition, as in we require food, water, oxygen, is similar throughout the globe. But does language change due to our immediate surroundings over time?
What puzzled Darwin and Wallace when they started trying to apply the idea of evolution to human beings is that human beings seem to be a lot smarter than they really need to be to do the kinds of things that we've been doing for most of our evolutionary history. To be a hunter-gatherer, it's not obvious why you need to have a language with a grammar that takes a 500-page book to describe. You could probably get by with a much simpler language. And some people in hunter-gatherer tribes have elaborate systems of mathematics or elaborate mythologies or elaborate forms of art that you also don't, it isn't really obvious why you need this just to hunt, pigs and gather vegetables in the forest. So it's a standing mystery about people. Why are their languages so poorly suited to their circumstances? Why are they so much more complicated than they need to be? And it really seems like the answer to that is that human culture, it isn't just about getting food and getting water and getting shelter. That people are interested in. What it all comes down to is status and courtship. That people are interested in being attractive to other people. There's a competition to be attractive to other people or to have some kind of position in society or to be looked at in a certain way or for people to think you're smart or for people to think you're a great artist. And what that's about, it isn't about getting food or water. It's about competing with your fellow humans for the good things that are available to the widely admired person. So there's no group of people anywhere in the world who have a simple language or a language that isn't rich or doesn't contain poetry or various sorts of fairly elaborate tools for poetic expression. What I think, but then the way in which modern people are living in agricultural societies is so completely different from the human norm, from the way people have lived for the last 200,000 years, that our languages have had to become quite different from the original human languages, the languages our ancestors would have spoken 50,000 years ago. And the big difference, it's always the big difference with modern people, is that people, for example, in classical Greece knew a lot less than we know, but they knew it much better. They were much more familiar with the things that they knew, and everybody knew way more the same stuff, so people could have much more intelligent conversations about the limited amount of stuff that they knew. We know a lot more, which is better in a way, but we don't know it as well, and each of us knows something different. So it's harder for a modern person to use his language to create a unified picture of his world, I guess is what I'm trying to say.
I really love the fact that you're able to weave in such deeper philosophical questions into the context of, say, language, which is what you do throughout the book. I think that's one of the beauties. I wish we had more time, but, I really just urge people to check it out and to think more deeply about this aspect and evolution and societal change through the lens of language, which you did. I really appreciate it. Is there anywhere else that you write that people can follow you, can check you out? I mean, this is your chance to kind of let people know. We will definitely link to your book on Smart People Podcast.
At the moment there's the book. I'm working on a bunch of shorter pieces that kind of extend the theory into talking about the arts and human sexuality and things like that. That stuff will be coming out in a lot of different forms. The easiest way for people to find out what I'm writing is just to look at my website, danielcloud.net.
danielcloud.net. That's what I was looking for. Well, Dan, I really enjoyed this. Thank you so much. I love your book. I love the angle you've taken on it, and I really appreciate you taking the time to talk to us on the show.
All right. Thanks for having me.
Another Smart People podcast in the books. I hope you guys enjoyed that episode with Daniel Cloud. If you've ever wondered why certain words are certain words and why we call them what we call them, check out his book, Domestication of Language. You can find it on Amazon and at bookstores. Don't forget the holiday season is coming up, so head over to smartpeoplepodcast.com and click the Amazon banner. When you do any of your shopping on Amazon, clicking the banner will help support the show at no cost to you. We truly do appreciate it every single time you guys make purchases on Amazon and use our banner, so please continue to do that. If you enjoyed the episode or any other episode of Smart People Podcast, please head over to iTunes or Stitcher and leave a review and comment over there. If you want to reach out to Chris or I, you can shoot us an email at smartpeoplepodcast@gmail.com or send us a message on Twitter at smartpeoplepod. We love hearing from you guys, so if you have any feedback about the show, please feel free to reach out, or if you have any suggestions for guests, we'd love to hear from you. Again, thank you very much for taking the time to download and listen to Smart People Podcast. We truly do appreciate it, and we'll see you guys next week.